Boyan Slat. Give him a big applause. Here you go.
Welcome to the Ocean Cleanup's prototype unveiling. In a few moments, we'll be showing you the Ocean Cleanup's prototype for the first time. But first, let's go back to why we're doing all this in the first place. This is a picture a team member of ours took in the heart of the Pacific Ocean last year. And this is what it now looks like when you drag a 1 meter wide net for 1 hour through the ocean at walking speed. And let's be clear, this is not how it's supposed to be like, okay? This is the concentration of about 10,000 times more plastic than naturally occurring sea life. And in fact, this is not all. Actually, when you look at the whole spectrum of size classes of plastic, what you see is that those microplastic are today actually just a small fraction of the plastic. But today, most of the mass of the plastic is stored in those big objects, things like bottles, buoys, crates, etc. And the thing is that all those large objects will become those very hazardous microplastics over the next few decades if we don't do anything about this. So then the question is this a future we accept will happen? Or do we want to create a future in which the oceans become clean again? Well, today we're here together, obviously, to talk about the second option. And I think really there is no other way to turn back the clock than to actually go out there and start cleaning up. Well, even before the Ocean Cleanup was founded, people already proposed to do so using vessels and nets. But the thing is, this would take quite a while. It would take about 79,000 years. And furthermore, it would be very harmful. It would be inefficient. It would cost tens of billions of dollars to do so. So not such an attractive proposal, I think. But then suddenly there was this one simple idea. Why move through the ocean if the ocean can move through you? So I came up with this passive system which would really allow the natural ocean currents to do the hard work for us. And because this array we started to develop is oriented in a V shape, the plastic would concentrate towards the center where we could then easily extract it and store it before shipping it to land for recycling. Computer models then showed that with a single one of those systems, deployed for 10 years, we should be able to clean up about half the Great Pacific Garbage Patch, or more if we would deploy more systems. Well, it sounds quite easy, but the thing is, because nobody's ever done anything that is really comparable to this, there are just so many unknowns that it becomes incredibly complicated. One example of that is, for example, that only about a year ago, some people told us there were tens of thousands of tons of plastic in the ocean, and other people told us it was tens of millions of tons of plastic. And as you can imagine, that's sort of quite a range. And for us to be able to clean this up, it's quite important to know how much plastic is out there. So in order to solve that, we came up with a little project we called the Mega Expedition. What we did was we crossed the Great Pacific Garbage Patch with 30 boats at the same time, taking more measurements in 3 weeks than in the preceding 40 years combined, to really produce the first high-resolution map of the garbage patch. And it wasn't only unique in terms of scale, it was also the first time anyone measured that large debris. So not just the microplastic, but also the macroplastic. So what we did was we fitted this vessel with these very large nets, and we're able to show that there's actually a lot more plastic out there than people thought, because nobody ever measured that big stuff. We had about 1.5 million pieces of plastic that our lab team counted piece by piece. And probably about around the end of the year, we should be ready to share the results of that expedition. And next, we started to develop the technology itself. So the way you develop something that is as new as the Ocean Cleanup is to really do it iteratively. So basically what we do is we use evolutionary principles to guide us to the destination, which is a system that would actually work. And I think this is a really, really important concept, because it means we test not to prove ourselves right, but to really look for the things that don't yet work and act accordingly. So how do you test often? How do you test cheaply? Well, you scale it down. So We first went to an institute called Deltares, where we did these tests at a very small scale, and then we moved over to a slightly bigger institute. This is Marin, where we deployed a 1:20 scale model. So that means that the waves you see here, although they look very small, actually represent about 10-meter high waves. So it's a pretty good test. Normally, oil companies, when they develop a new oil rig, they test it in this particular basin before actually putting in $1 billion and constructing it. So good test, and we learned a lot of how the thing behaves, how much force goes through the barrier, as well as how the water flows underneath it. So it's really good testing. But there are some things which really cannot be tested in a scale model basin, which leads us to the North Sea prototype. Can we build a system which is able to survive on the ocean for years? That is the key question we're trying to answer here with the North Sea prototype. And to do that, we actually need to go to the full scale. But the thing is, full scale in the North Sea, 100 kilometers, it will be pretty expensive, it would be quite risky. So in order to solve that, what we did was, instead of testing the whole system, we're testing a segment, because the system is actually very modular, so we can test one system. If that would survive, the whole thing would survive as well. So it's a 100-meter system. It will be deployed 23 kilometers off the coast of the Netherlands, and it will stay out there for a year, which means that we would get all seasons. And kind of the neat thing about this testing location we've gotten from the Dutch government is that because the currents are so strong because of the tides, in the first minor storm, we'll get forces higher than during a 100-year storm in the Pacific Ocean. So it's pretty safe to say if it survives here, it will survive anywhere. Let me describe the system to you in three points. So first of all, it's strong. It's probably the strongest floating barrier anywhere in the world. It's made out of 10 different layers of rubber, polyester, fabric. Developed in conjunction with our partner Desmi there from Denmark. It's designed to survive loads of up to 80 tons. So what is 80 tons? Well, it means that basically if a car, like a small car, would press against every meter of the barrier, it would still be able to survive that. And the way we are carrying the loads is through a DSM Dyneema cable underneath the barrier. And this is actually a cut-proof barrier, so it would even survive if, for example, a shark would bite on it. So we pretty much covered those things. Secondly, it's quite big. It's about 1.5 meters below the water and 1.5 meters above the water. And we did this because we want to make sure we will be able to catch pieces as small as just a few millimeters, but also as large as, say, a ghost net, which is several meters in across. And lastly, it is smart. So to maximize the learning we get from the prototype, we pretty much fitted the prototype with as many sensors as we can. So we have motion sensors in the barrier that are able to detect even if, for example, a seagull would land on it. We have force sensors throughout the whole system to make sure we can measure how much force the current and waves is exerting on it. And we also have camera systems so that we will be able to monitor the system from our mission control in Delft 24/7. So perhaps we should count to 3 or count from 3 or something like that. So let's start on 3, okay? So here we go. 3, 2, 1. Say hello to the Ocean Cleanup's prototype. In a bit, you can see actually how big it is. Just imagine that in a few years from now, it will actually be 1,000 times larger than this. So it's a pretty big system. And just to have a better illustration of actually how big this whole system is, perhaps we should turn around and just look at what's behind the other curtain. So let's take a moment to turn around. Mitchell, if you can drop the other curtain, please. If all goes well, we should be ready to deploy the first operational pilot around the end of next year. and that should put us on track to initiate the largest cleanup in history by 2020. So, although today is a historic day for us, let me just conclude by saying this is not the end, it's for us just the beginning. Thank you very much.
Ladies and gentlemen, Boyan Slat. Thank you so much.